All right, just a little reminder that this is the review. So, if you're going through this material for the first time, this is not the video series that you would want to watch. You'd want to watch the one where we take our time, go through and explain the material. But this is just a very quick hit review of the subject so that gives you an opportunity to see that material for a second time. This, of course, is after you've read the material, and I would definitely suggest reading the material again before we even start on this. There'll be reminders in here of page numbers and where to review, so you can choose what works best for you, whether you read it beforehand or read it as we come through here. So chapter 2 is out of our book, pages 35 through 76. And this is our cloud networking and storage section. Now, these are two very separate subjects, but our book puts them together and it makes sense because what they're trying to do is get the technical things out of the way. So chapters 1, 2, and part of chapter 3 are very, very technical in nature. And then the rest of the book is more focused on the business aspect of it. So if you're coming in here, and of course, when we start talking about network, that can be some of the most technical things that we discuss. So if you start to feel like the material's over your head, don't worry about it. There's not a ton of things you need to know. But then on the flip side, if you study this material and it turns out that you really, really find that you're interested in this, be sure and look for those opportunities. There are plenty of networking opportunities. It's not something I've ever explored, but there are there always has to be really good networking people, and they're also the backbone of a lot of the security items that we do. So you'll learn a little bit more about this. And like I say, as I'm going through and I'm giving you the high level technical, if this is something that you really are interested in, just get excited because there's a great future for you there. So some of the things that we're going to discuss here in chapter 2 is the two major sections: identifying cloud networking concepts and then identifying our cloud storage technologies. So within the networking, we're going to talk about connectivity types, common access types, software-defined networking or SDN. And then when we get to the cloud section, we're going to learn about storage features, storage characteristics, and the different types of storage that we have. All right, so the introduction is on page 35. And just some of the highlights here, you can take the time to read through that introduction. But it's talking about how when the internet was popular, cloud technology um, founded in the periphery of computing technology. This is despite the core technology, the virtualization, having been in existence for nearly 3 decades. So, what this is saying is that we have always had the ability for virtualization, and it was very handy even in the 90s and the 2000s. And then even a little bit before that, but inside of our own data centers, people would utilize virtualization techniques. And you've learned about these. It's with a hypervisor, making a really large machine, being able to be split up into smaller machines, and doing the same thing with our storage. And we'll learn a little bit more about that a little later here. But even though we had that capability for the hypervisor and the virtualization, we needed that internet backbone to come along. And so finally, enough fiber got laid and people's internet speeds are faster. So now we can actually use this cloud um, in a commercial way. So that's, it's kind of neat that we had that opportunity as an industry to um, to get really good at cloud. And then after these organizations got really good at virtualization in cloud, we had these CSPs pop up: Amazon, um, Azure, Microsoft Azure, Google, to allow us to have that knowledge and understand what it is. And then we could go to the commercial CSPs and do that. So this is a very interesting chapter talking about our networking and what it took to get us here. All right, so some of the things we're here: understanding cloud networking, how do users access virtualized cloud resources, why do we want to use virtualized servers, what are some of the benefits, and then what are some of the risks. So the first thing we need to do is kind of have a quick primer, and that's what this chapter starts out as. If you know nothing about networking, it's giving you the high level things that you need to know about networking in order to understand all of the cloud concepts. And if you are an expert in networking, it's not bad to run through that little primer, make sure we're all talking the same language, and to understand that. So if you haven't already, be sure and read the quick primer on page 36. But in short here, what is a network? So a network is two or more devices that can communicate with each other. This requires software, like a network client or built into the OS, hardware with a network adapter, network card, and then transmission method or networking protocol. So nearly every computing device today has a built-in network adapter or an NIC, Ethernet, cellular, or Bluetooth. Now, when I first started getting involved in computers in the 90s, this was not the case. You very well could have a computer that had no way to connect to any kind of a network. It sat in your house. It was a word processor. You could play games on it. You hooked it up to a printer. So your input was a disk, keyboard, the standard ways that we would input into our computer. But then the output was a printer. It was a little bit simpler days. But then, of course, with the advent of the internet, and even before the internet, there were bulletin boards and there were things that you could sign into. So network cards started becoming pretty standard in our computers. But now a network interface is pretty standard in just about every type of computer that we have, or every type of technology we have. But nowadays, every type of device that we add usually comes with some kind of network interface. Heck, even in our homes, now you can hardly buy a garage door opener that doesn't come with some kind of network interface, whether that be wireless or wired. It's pretty standard for every piece of technology now to come with some way to access the internet. So here is in our primer. Um, there used to be a lot more of these socket type of devices, and thank goodness we kind of standardized it as an industry and brought it down into a more manageable list. So there are still things that are outside of this list, but this is what we consider our TCP IP protocol suite. It's based on the US Department of Defense, and the layers are responsible for different tasks. So, some of the things that we look at here, again, this is the DoD model. Um, let's start here at the bottom with things that we really understand. So, network access. This could be Ethernet, that's the plug that plugs into the back of your computer, fast Ethernet, gigabyte Ethernet, and then the one that we're more familiar with now, 802.11 Wi Fi. So, if you walk into a coffee shop, you know how to hook up to the Wi-Fi there. And then also, if you walk into an office building, we this is the standard way that we connect now. We don't generally hook up network cables like we used to, but if you want something to be solid and fast, that's still possibility. And then we take one step up the ladder here, and we look at our internet. We have ICVMP, ARP, RARP, and all of these things require an IP or an IP address. So we'll talk a little bit more about IP addresses later in the chapter, but in short, everything that sits on the network has to have an IP address so that we know what it is and what its function is. Then we have our host to host. This is like TCP and UDP. And then we have our process and applications. So, for Telnet, this is how you connect into another computer, DHCP, RDP, SMTP, SSH, secure shell, HTTPS, HTTPS secured, and then FTP, which is file transfer protocol. So this is the model, and these are the things we use whenever we're connecting network enabled devices onto our network, and what standards we use when we're connecting with those. Okay, so the first thing we want to talk about here is connecting to the cloud. So um, the way we connect to the cloud, we use Hypertext Transfer Protocol Secure. And the way you can tell it's secure is it does have this S. And then we also use Remote Desktop Protocol using Secure Shell, using Virtual Private Network, and then using Direct Connect. So we're going to dive into each one of these individually here. So when we're using Hypertext Transfer Protocol Secure, this is how we access things via a web browser. So right here is that S. That's how we know that we're in the secure level. So web browsers, many users connect individually. And then, of course, the S, this means it's encrypted in transit. So there's no way anybody can see what you're doing. Now, if it doesn't have the S, if you're just using HTTP, then people, that want to be able to do that and are experts in hacking are able to get in and see what type of activity you have going on back and forth. But when you have the S, you're encrypted in transit. All right. And then the other way we connect to the cloud is using remote desktop protocol. So using a remote desktop protocol, after you create a virtual machine, you can connect to it just like it was in your data center or your office or your home. Many uses, extra server capacity, tests software on multiple operating systems, creating test environment. So you connect using an RDP desktop protocol. So this is what it looks like here. For Windows, you establish a connection using remote desktop connection. There's a couple of different versions of the software that you can use. This is the standard one with Windows. And then you can also get some that are just a tad bit better, a little bit more secured, and you can remote desktop into those. So you connect via an IP address, use security key pairs, public and private key pairs. And then we're not going to watch this now on the review, but if you want to, you can come in here and watch this video, and it will talk to you a little bit more detailed about what's in our key pairs. Okay. I thought I had separate slides for this. This is just one slide. Usually whenever we connect to a Windows desktop, we use the remote desktop connection. But then whenever we are connecting into a Linux machine or a Unix machine, that's when we establish a key pair. And again, not something that you do all the time, and not something you ever need to be an expert in, because if you're going to do this, you'll follow a set of steps to teach how to do this. And part of this video that I have here that you can watch shows how to actually create that pair so that you can connect via a Linux environment. And then AWS, if you want to use their command line interface, they also have a way for you to do that with key pairs. All right, and then the next one on our list was using Secure Shell or SSH. So SSH is to Linux instance what RDP is to Windows server instances. So you can run from a command prompt, or you can use software such as PuTTY, which is an emulator that you can sign into, and it's on your desktop. It looks like it's running on your desktop, but you're actually connecting into a Linux environment. It looks very similar to the command prompt on your Windows machine if you haven't ever seen one. But you can change the background, change the colors, and you can do a lot of things. And it's pretty standard practice for anybody that works in Linux. All right. And then we also are talking about using a virtual private network. So a VPN is a secure or private network connection that occurs through a public network. VPNs can be used to connect individual users to a corporate network or server, or to connect company networks or clouds together across the internet or other public networks. So you can use a point to point. It has a secure tunnel, and it's through the internet. So here you would have your home laptop, and then here's your broadband connection. You're going through the internet, and then when you hit the VPN right here, and this is your corporate network, and then you can have access to the things that are inside that network. So we refer to this as the VPN tunnel. Again, this is your network primer. This doesn't necessarily describe cloud, but this is just your standard practice for how you connect into these. Our cloud's going to add a few aspects to this. And then here, connecting to the cloud using Direct Connect. So provide a physical connection between your company's on-prem and the CSPs. So anytime you're talking about connecting your data center or your office directly into one of the CSPs, we have that capability. And each of them work kind of similar, but a little bit different. But you sign into the console and you order up this access. And then sometimes you have to work with an outside telephony partner. Sometimes AWS or Microsoft will help you. Just depends on what your setup is. But they have different names. I don't think you'll be tested on these, but I wanted to show you that Azure is called ExpressRoute. The one for AWS is called Direct Connect, and then Google has one called Google Cloud Interconnect. All right, so then now we're going to talk about our cloud networking services. So as a reminder, we're always talking about usually you can either say big three or big four. To replace your data center, you need the big three: compute, storage, and networking. Some books, some people put databases inside the infrastructure layer. I don't really think that it necessarily belongs there because you can choose how to use your database. You can go in and you can create a virtual machine and install the database software on top of that, just like you would if it was in your data center, or you can go purchase the database directly through the cloud service provider and something that we call a RDS instance, and the CSP will run the database and do all the back end processing. You only create the database, create the tables, load the tables, and use the database. All the database administration gets done at the CSP level. So when we're talking about the network services, what I'm pointing out in here is that you have your big four cloud services, and beyond that are services, lots and lots of services. So we'll talk about some of those others, but in here we're just talking about the core networking services. So some of the core networking services, probably one of the most powerful things, and one of the things that makes all of the selling points of why we tell people to go to the cloud. We tell people, say, look, if you go to the cloud and you have an issue in one place, we can automatically fail you over to another place. And it all works. Well, the way that works is to have a load balancer there. So you have these incoming requests right here, and they come into the load balancer, and then here are the systems. So the incoming request goes to the load balancer. This guy has no idea what's behind here. It doesn't know if there's one place, two places, or three, but the load balancer does. So it takes the request, throws it over here, returns the processing, and gives it back to the user. So this is the concept that we've talked about many, many times, where if I have 5 users, they're on one server, but then, I get a few more users and I have to spin up another server. And then if I get about 10 to 15 users, I have to spin up yet another server. This load balancer is that smart thing that makes that work. We have our auto scaling actions, and everything that's behind that, but it's the load balancer that's keeping track of how this works. So there's several different kinds of load balancers. And as a matter of fact, I have 2 videos here we're not going to watch during this review, but if you would like to pull these slides up and click on those and review those, we talk about what load balancing is, and then we also have a video on the AWS load balancer. So what's the benefit of this? Performance. As I mentioned, let's say that, whenever we reach a certain threshold, we spin up more machines. This is what's going to keep our performance up, our scalability. If we have one machine, if we keep beating it and keep adding people to it and keep adding commands to it, it's going to spin up and eventually run out of space. So if we can expand, that's how we scale out. And then our reliability, of course. If these look like they're in different geographical locations, the way this the art is on this slide here. So let's say that there was some issue here, a widespread power failure. Well, if this goes completely out, it's okay because we have other environments. Our end user here that's sending requests never even has to know that an entire data center went down out here. So that's part of our reliability. All right, some more of our cloud networking services. So all of the CSPs have to have something for 2 aspects of this: domain name system, and then also, I'll say the also for when we're done with the rest of this. But with a DNS, essentially what it is it's a server that you send an IP address to, and it returns the name of the server, or you send the name of the server and it returns the IP address. So the reason we do this is because we don't want our IPs in the code. We don't want our IP addresses being hard coded anywhere and utilized. We want to use a friendly name and go get the appropriate IP address. This is handy for many reasons. First of all, you don't have to remember what that IP address is. And the second thing is we can change it in the back end. So let's say that right now we are sending everybody to a certain server when they type in a friendly name, like, a friendly name is like google.com, example.com. And we're sending people, we go grab the IP and send them to where that is. So that's why we want to have this domain name system. Well, let's say that that system went down. Now we go to the DNS system and change that IP address. We didn't have to go change 1,000 places. Everybody's going to that same location to pull back where to go when this name comes up. So that's a very simplified example, but something that I want you to understand. That's the intended purpose of a domain naming system. Again, it does a little bit more. You can do more research, but for our purposes, that's all we really need to know. So our CSPs each have their own solutions. So with Amazon Web Services, they have Route 53. With Azure, they have Azure Traffic Manager. And then with Google Cloud, they have something called Google Cloud DNS. I will tell you also that Route 53 doubles. It also does the domain name system, but it also does registration, domain registration. So if you want to go get a web address, like you wanted to go get jeffratcliffe.net, you can go there, open it up in Route 53, see how much it would cost per year. It's usually around $12 unless you get a more specialized one. And you can purchase it right there, and you're the only one in the world that can use that because it goes to a domain naming system or domain tracker. And so all of these companies like GoDaddy.com that you can purchase these web names, they are a registration service. So they register it, and so you own it at a global level. Nobody else can own the same one that you own. So Route 53 also performs that function. All right, next thing we're going to talk about here is our cloud networking services. These, some more of these services, and that's all we've been talking about here so far is all of our networking services. We can also use firewalls, hardware or software solutions, network security guard, and a DMZ. So let me kind of show you what this is, 2 ways to configure a DMZ. So here's one. Here's the internet and the traffic that's coming in. Here's a firewall. And if you don't know what a firewall is, remember it's just what it does is it blocks all traffic until you poke a hole in it. So you give certain areas that if people know where to go, they can get into your firewall. So that it's a secured level. It's not like a password because it's has other security features associated with it as well. But in short, what it's doing is it says all traffic is blocked except for a certain port. And then when you get into that port, you have to have added security there. Trust me, it saves a lot of issues by having that port level access. So then once you get through the firewall, you can get to the internal network. And then also, if you can get through, you can get to the DMZ. So DMZ is a military term. It stands for demilitarized zone. So if you're out in a if the Army sets up a DMZ, they protect it and make sure that absolutely nothing can get back into where that is. So a DMZ, demilitarized zone, is a very, very secured area that absolutely nothing can get through. And then the other thought here and the other configuration is to have 2 firewalls. So you have the internet and you go to the firewall. And then if you know where you're going, you can get in through the DMZ. But then here, they've also added another firewall so that the internal network can't get to the DMZ either. Not easily anyway. So they set it up so it's doubly secured. So this is a true DMZ area that it's very, very difficult to get into. And really, I'm not going to say impossible, nothing's impossible, but it's supposed to be next to impossible for anybody that is not supposed to be in this DMZ area to be in. And again, remember I told you when we started, if you do enjoy this and you like the networking side, I was telling you, networking is where most of our security layer lies. I mean, I shouldn't say most, but I mean, I guess, well, it is most. There's still a lot of things you can do from an application level and different things, but most security tools, what they're doing is stopping traffic from getting to where they shouldn't be. All right. So now we're going to move on to section 2. Again, there you can study networking. There are books and books and books on networking. There are different tools. It is a study as broad as if I said software development. If I said software development, there's lots and lots of things you can do in software development. You could go the Python way. You could go all the way back and do mainframe days, COBOL. There are hundreds and hundreds of languages, many, many things. So if I went to one class and I learned something about software development, I just scratched the surface. Well, we have just scratched the surface of networking. Many, many more things in networking, but that's all we need to know for this class and for this certification. So now we're going to jump into our second subject of the class here, and it's understanding our cloud storage technologies. So when we talk about cloud storage, I've mentioned this a couple of times in the course. Storage is the first thing that people trusted the cloud for. And even today, when you're migrating people out of their own systems and out of their data centers, storage is the first one that you can talk people into doing. And here's why: because storage, we understand it. We have files. We know that some people need access to write files, some people need access to just read files. So it's a much easier thing for us to comprehend moving out of our control and into, I'm going to say, the internet, moving it outside of our data center and letting somebody else handle that. So we're gonna learn a lot more details about what's in here, but some of the storage options that we think of whenever we're um, talking about storage, we're all aware of things like Dropbox, Amazon Drive, OneDrive, Google Drive, iCloud. We understand the concept of a lot of people. iCloud is one of the first ones they use. They'll spend $1.50 a month to make sure that they can get twice the storage and they can store all of their music, all of their pictures, everything that's on their phone. And then, we've in this class have explored Google. So by now you probably are very, very familiar with Google Drive. I've been using that for, I wouldn't even know, probably 15 years now, where I keep my files out there and I can access them from any computer. I can also make it look like it's a drive sitting here on the computer that's in front of me. And that way, those files are safe. I can get to them everywhere and they're backed up. OneDrive, same thing with Microsoft, a little bit more advanced. You may or may not be exposed to that, but if you understand the concept of Google Drive, you understand the concept of OneDrive. Amazon Drive, same thing. It's an Amazon product. Probably not something you as a consumer have used, but you could have. They're just not out trying to sell it as much as some of the others. And then Dropbox is a completely separate solution that really, really focuses on the concept of storing your files, sharing your files, letting a group of people access your files. So we all have a really good idea of what storage is when we walk in here. This is a simpler thing for us to comprehend. So here's the key aspect of what this is. So in our minds, first time you use Google Drive, before you were exposed to much IT knowledge, you didn't think about it much other than, oh, that's a drive. It's a drive that's sitting out on there on the internet. I can drag and drop files to. I can double click on them just like it's sitting on my hard drive. But you don't think about everything that goes into it. Now that you've been exposed to cloud, you know that that drive's not just one drive. That drive out there isn't, it's sitting somewhere in some data center on a drive, but where it is today might not be where it is tomorrow. So we have to, and then also we know that it's being backed up multiple places. So if one area of the country went dark, the power was cut, there was a flood, there was a disaster, we know we're not losing our files because our files are backed up everywhere. You may not know everywhere that it is. You just know that Google's taking care of it, Microsoft's taking care of it. So the way this magic works is with software-defined storage or SDS. So the physical storage of the data is separated from the logical control or drive configuration and independent of the underlying hardware. So we can look here in this figure 2.15. We have our cloud-defined storage. So the user is going here and says, put this on my drive. But what's going on in the background, we have the storage volumes, multiple servers, so it knows where your stuff is. So it can display it and let you use it. It's also being backed up over here. And then, the physical hard drive is over here. This guy doesn't even think about terms of where this thing is actually sitting. It's sitting somewhere in some data center right here. But right out here are the volumes that they know the address of where that is, and they're able to pull up the actual file when you're wanting to do it. And then if you overwrite the file, this guy handles how and where and all the locations that file actually gets updated. All right, a few things on cloud storage. Scalability, it grows as much as you need. Transparency, how much storage and how much it costs. Oh, how much is storage and how much it costs. Standard interface, it's easy for admins and clients. And then storage type, support, object, file, and block. So we're going to go into a little bit more detail on each of these sections here. So first thing we're going to do is look at some of the strengths and weaknesses of and the price difference in the storage things that we know. So when you get into the cloud and you're working with Amazon and you're working with Microsoft and you're working with Google, you'll get to see a different style of price sheet. But what we're looking at here is from a consumer standpoint. So here are the ones we know: Dropbox, Box, Google Drive, OneDrive, Amazon Web Services, and iCloud. So some of the strengths, and let's just go down this and look at this. What are the strengths here? So with Dropbox, ease of use, multiple devices, automatic cloud backups. With Box, administrative controls. With Google Drive, it's part of Google Apps. We can use it with our email. We can use it within our file structures. It just goes along with the tools that we're already using. Microsoft OneDrive. It's designed for business. Cloud storage is available a la carte, or part of Office 365. What I like about it is it's hooked in with my computer. So I have a personal one. I also have work ones. All within the span of a couple of weeks, I changed my work computer and my home computer. And it was very nice to sign into OneDrive. And I just let it go and it goes in the background. If I went and double clicked on one of my files, if it hadn't been pulled down yet, it would go ahead and go grab that one and bring it down. Very, very smart. So it was designed for business, but the consumer um, experience is really, really good. That's why it cost a little bit more. But anyway, so back in the day, I remember getting a new computer was a 3 or 4 day event, especially if you were a nerd like me and wanted to get all your tools and everything set up. It was a long time. But now you buy a new computer, you just sign in and hit a couple of buttons. It'll even ask you if you want all the applications that were on your old computer moved over to the new one, and it will download those or at least put an icon there. So the first time you click on it, it brings it up. So anyway, that's a lot of the strengths of OneDrive. Amazon Web Services, flexibility, options for developers, pay-as-you-go pricing, and then with iCloud, works well across multiple Apple devices. Now, one thing, if you'll remember, when I showed you how cheap these were, and I guess we'll talk about this here in just a moment. When you're going in here and you look at how cheap like Amazon Web Services storage is, and you're thinking, why in the world am I spending $9 a month or even $1.50 a month when storage is so cheap? You're paying for the interface. You're paying for the ability for your files to be there, and for it to everything in the background to take care of itself. All you're doing is looking at something that makes it look very, very simple. All right, so now let's look at the weaknesses. So with Dropbox, fewer IT admin controls over other cloud storage services. With Box, can seem overwhelming to use for non-technical employees. Google Drive, no option to buy Google Drive as a standalone service for business. So yeah, it is. It's very tied into your Google Drive. OneDrive file organization systems take some getting used to. Amazon Web Services complexity makes it difficult to use for non-technical users. Like I said, it's very cheap, but if theirs is just a click and drag type of thing, you have to put all your controls on top of it to make that a powerful thing. And then with iCloud, it's designed for personal use, but not business purposes. Does not integrate well with other services, difficult to share files or collaborate because that's not what it's really designed for. And then here we'll talk about the personal and business cost here. With Dropbox, you can get 2 GB completely for free, 1 TB for $9.99 a month. And then for business, you get 1 TB for $8.25 per user per month. Business for teams, as much space as needed. And then we look here at the box. Personal Pro is 100 GB for $10. Over here, it's $5 for a business, and then 15 for unlimited storage. Then we go to Google Drive, 15 gigabytes for free. 100 GB is $100.99 a month. Terabyte is $9.99 a month. 10 TB, $99 a month. Google Apps, for business, you can get it for $5 per user, unlimited storage. And then over here, let's see, OneDrive. It says not personal, but there is personal. But I guess there's no difference between the two. You get 1 TB for $5 a month, 5 TB for $10 a month. Amazon, no personal, because without Amazon Web Services, you can't get to it. And then for business, wide variety of pricing options, dirt cheap. If we don't do this in the review, you can go back and look at the others. You'll remember it's like 2.5 cents per gigabyte per month. It's very cheap. And then with iCloud, you get 5 GB for free, 50 for 99 cents a month. So we'll just leave it at that. You can get more, but unless you're completely in Mac world and iPhone world, it doesn't do you much good to do that. All right, a little bit more on the storage characteristics. Takes a little bit of time to look through, and you do want to know this before you set for your certification. But just it's pretty easy once you understand what it is, and don't stress out about it. Don't think you have to memorize the whole table, but just know that in most cases, hot is good, cold is not as good. But some of the characteristics. So with Microsoft Azure, you speak in terms of premium, hot, cool, archive tiers. With Google, they have multi-regional or regional, which is hot. Nearline or code line is cold. And then with Amazon, they have two object level versions. They have simple storage service, and then they also have Glacier for archival of data. You're not going to be asked any details on that, but Amazon just kind of owns the market on object level storage. They handle it better, and they give you a little bit better options for long term archival of data. So here are some of the traits: access frequency. So let's just run down the trait list. So access frequency, you're going to pay more if you need to access it right away. You're going to pay less if you don't. Trait access speed. So the faster you have access to it, the more you're going to pay. The less speed you use, the slower. And this also comes into one thing you can think about here is spinning drives versus solid state drives. So solid state drives, as we know, are faster. Spinning drives are cheap, but they're not very fast. And so that's what you have to think about. Then media type and cost per gigabyte. So we'll do the hot and cold. So frequency, hot is frequent, cold infrequent. Speed, fast is hot, cold is slow. Media type, hot is fast hard drives, such as solid state drives. Cold, slower hard drives, such as conventional hard drives or HDDs. Tape drives and offline. And then the cost per gigabyte, of course, hot is going to cost more, cold is going to cost less. All right, a little bit on our storage types. Again, this is something you might have to take a few notes on, study your book a little bit more if you don't know what this is. But we have file storage. Like filing cabinet, Windows uses New Technology File System, or NTFS. Macs use Apple File System, APFS, and Linux uses the fourth extended file system, or the ext4. So here's a little picture of your file storage. And this is what it looks like on a Windows machine. And then if you move into a Linux machine, it's going to look kind of similar. You'll have backslashes instead, forward slashes instead of folders, but it's the very same concept. You can think of them in the exact same way, especially even if you're using those systems. But this is a file system. It's not attached to your computer. Many computers can attach to the file system. That's what makes it different. So we'll talk a little bit more about that later. All right, the next storage type. So we talked about file storage. Now we're talking about block storage. So this is big chunks of data. So block storage is it puts your hard drive into different blocks. Now there's lots of reasons it does this. This makes it faster and makes it better, but here's one of the best features of block storage, and one that you might actually be asked about is at the end of the day, let's say this is my hard drive and I have it split up into 40 sections. My system keeps track if I've overwritten any data that's in any one of these blocks. So let's say at the end of the day, I've only written 2 times and I updated block 1 and block 32. Well, in the backup procedure that night, it's not going to start with 0 and go all the way through 40. It is going to back up whichever ones changed. I think I said 1 and 32. So the backup that night is only going to update these two and store them. So lots of good features of block storage, but that backup and retrieval is one of the best because it keeps track of just what did change. You don't have to back everything up. All right, and then finally, the one that is storage for the internet, storage for um, cloud is this concept of object level storage. So this is one of the flagship cloud products. As a matter of fact, it's the very first one that Amazon put out there. And essentially what it is a folder. And you can put your objects inside that folder and you can define who can access it and who can do what. And this goes back to that concept of some people need to be able to write the data, and some people need to be able to just read the data. So, one of the best examples I can think of is like a music service. So, the person who owns the service needs to be able to put new music out there. And then the people that pay for the service, the owner can grant them access to certain pieces of music, and then that the user can go out and double click on the music and play it. So that's a very simplified version because we all know how these systems work conceptually anyway. So this object level storage is for easy retrieval. The data is the file itself. The metadata keeps the data about the data, attributes, classifications, and it has a unique ID. So when you're talking about the metadata, think of like picture data. How now you can look at your phone. If you have your GPS turned on, you can tell where a picture was taken. You can tell to the exact second when it was taken. All of those things are the metadata. All right. So then the next thing we're going to look at here is cloud storage. So some of our features, compression, deduplication, and capacity on demand. So compression makes files smaller so they take up less space. Deduplication is file level or block level to eliminate duplicate data. Think about like on your where you store your pictures. I know like my wife and I, we share a space. Sometimes we're on vacation and she says, "Hey, send me those files so that I can, do something with them. I can send them to somebody." So I send them to her. Now we have two versions of the pictures. Both of our phones update. They throw the pictures into the same file. And until we do something about it, there are two versions of that file sitting out there and they just put, they add something to make the name just slightly different. But in good cloud storage things, it would go through and determine it's the same picture. It would delete one and save the other. Most of your consumer products aren't going to do that, but your business products, you would want to be able to do that. So then our capacity on demand. So this is one of the coolest features. So let's say in our data center, I want to have 10 terabytes worth of storage. I have to go purchase all of it. It's not like I can just purchase what I'm going to use. I have to order the disk, bring them in, and install them. But with cloud, you don't have to do that. There is no how big is this going to be. It's unlimited how big it's going to be. You only pay for what you use. Now, the other great thing about this is that you don't own the disk, so your data gets moved around and it gets put on new disk. In your data center, you purchase the disk today, 10 years from now, the disk they're sitting on is 10 years old. But in the cloud, because of our software defined systems, it's not sitting on an old disk. It's always getting moved around and it's on up to date information. And so you only pay for what you need. Again, key aspect of cloud is you only pay for what you need. All right, next subject here in our, I think it's our last subject here, is our content delivery networks. So I've talked about content delivery networks multiple times throughout the course. This is your introduction in the review to it. But remember, content delivery network, our data centers, our CSPs will have, Amazon says they have 31 data centers. Microsoft says they have 64 data centers across the globe. But their content delivery is more than 10 times that. I think Amazon says they have over 600 content delivery networks, Microsoft even more. And there are even small companies out there that you've never heard of that have content delivery networks. So think of it like, when you first start thinking about it, think of it like a newspaper. Let's say this is the home of the newspaper. These are the different states where people are going to read the newspaper. So it starts here, and then it submits copies out there. And then let's say, oops, we messed up the news. We got to fix something on that. So they throw it here, and it automatically flows out to all of the other data centers. These little data centers are called edge locations, or here it's called an edge server. So a couple of words that go with this: point of presence. So again, think of this as New York Times, and it's putting the newspaper out there close to the user. Now, after you think of that simple thing, then you think of something a little more complex. Let's say this is Netflix. Netflix gets a new movie in. There are people here that are these people that live around here. This is their server. People that live around here. This is their server. So whenever that new movie gets put out there on the server, the users can click, and they're not going all the way back to the home system to watch the movie. They're watching the one that's sitting here on this. So there is any number of use cases that this goes along with. I think throughout the course, I told you about some, like I work with a content delivery network where I have to upload a bunch of files. And so let's say that I'm way out here. They have it reverse engineered so that I throw my files right here and they go fast. I've mentioned this before. I have 50 something files that I have to move once a month. And usually when I'm putting it on my own network, it takes about 30 minutes. But then when I'm uploading it for one of my customers, it only takes about 3 minutes. I throw it out there and it just goes boom, and it's so fast. And what the reason that is I'm throwing these on a server that's probably sitting somewhere in Kansas City, if not Kansas City, very, very close. It takes 30 seconds for those files to go there. And then this propagates this out. So it sends it back to the host, and the host sends it to all of the other locations. So content delivery networks, fascinating concept, something that you can think about, and lots of use cases and lots of opportunities for new business ventures. So think about that if you're trying to think of some kind of really good idea for yourself or your company. So now we'll go down our list here. Creates a point of presence. That's what this is. The pop increases web performance, faster load times, increased reliability, decreased bandwidth cost, greater scalability, and increases security. All right, that was very, very fast. But what we talked about here in this chapter, we covered networking and storage. We did the network services. Remember, we talked about a lot of different services. We have a software-defined networking, load balancing, and firewalls. And then we talked about our cloud storage. Software defined storage, providers and plans, storage types, were file, block, and object, storage features, compression, deduplication, and capacity on demand. And then we finish up the chapter talking about our content delivery network. Okay, so now we have our exam essentials. And as you remember, the exam essentials are kind of like our flashcards. These are all of the facts that you need to know in order to sit for the certification. So what's cool about this is you go through, and I mean, within the material, there's some stuff that's added, but this right here, you need to know everything that's on these. So it's a really good way to tell if you're ready for that exam or if you need to do a little more study. So we'll jump right in here. How to know how to connect to a cloud with HTTPS. So Hypertext Transfer Protocol Secure is used by a web browser such as Google Chrome, Microsoft Edge, Apple Safari to connect to a URL for the cloud resource. Know what an RDP is used for. Know what RDP is used for. RDP is Remote Desktop Protocol. It's used to connect to a remote Windows-based server. Know what SSH is? That's Secure Shell is used to connect to a remote Linux-based server. Understand how VPNs are used. A virtual private network is a secure tunnel through an unsecured network, such as the internet. VPNs can be used to connect to an individual user to a cloud server, so they can also be used to connect to a corporate site to another. Know what a direct connect should be used. Know when a direct connect should be used. If a company needs to make extensive use of cloud services and have very little delay, direct connect between that company's network and the CSP network might be the best option. So just remember that direct connect means you're connecting your data center or your office directly to the CSP. Know which connectivity methods are secure. HTTPS, RDP, SSH, and VPNs all have built-in encryption. A direct connection should be secure as well, provided it's configured properly. Understand what SDN is. So remember, this is our software-defined network. The physical routing of packets is separated from the logical control of where the packets should be routed to. SDN provides flexibility and scalability for corporate networks in the cloud. Know what a load balancer does? Load balancing is a set of servers configured to perform the same task. They can speed up network performance by sending tasks to the server that has the most capacity. Understand what DNS does? Domain naming system resolves host names to an IP address. Understand what a firewall does? Firewall is a security device that protects computers or networks from malicious network traffic. Know what file compression is? File compression makes files smaller to take up less room when they are stored. It works by looking for repeated words or phrases within a file and replacing them with a shortened version. Understand the difference between file compression and deduplication. So file compression works within a file, deduplication works between files. So for example, there are 10 copies of a Word document. Deduplication file system will store only one copy of it and replace the others with pointers to the original file. Know what capacity on demand is? With capacity on demand, clients get more storage space from their CSPs nearly instantly. Understand hot versus cold storage and the performance implication of each. So hot storage is online and always accessible. Cold storage may be offline or on tapes. It's more expensive per gigabyte, but the performance is much faster. Understand when to use file block or object storage. So file storage is used on a personal computer from many servers and works best for smaller storage solutions. Block storage is best suited for databases and large-scale, frequently accessed storage solutions, such as those found in SAN. And then object storage is great for unstructured or big data for large computer or network data backups. Know what SDS is? With the software-defined storage, the physical storage medium is abstracted from the user and controlled by a central server. This allows storage volumes to span physical devices or many storage volumes to be held within one physical device. Understand what a CDN is? Content Delivery Network is a load balancer for web based content. Edge servers in remote locations, service users who are in close proximity to them, and they are to the original web server.